Hello, everyone. Thank you for joining. My name is Viktor Plézer, and I'm representing Instructure today. I'm a mobile development lead at Instructure. We are working on an application for both Android and iOS. So in the last 8 years, I was working on, so complete the sentence. Basically, I was working on both of these. So I was working on financial, banking, strong authentication, travel, blah, blah, applications for both Android and iOS. And by developing these, I came to the conclusion that every mobile software has a common theme. And these are bugs. So raise your hand, people who had any experience with bugs before. Okay, shame on you. A bunch of bug writers. So complete the sentence again. And I would just highlight the point G. So in the last 8 years, I was delayed, frustrated, and pulled back because of bugs. So yeah, here I am today with you, the anonymous bug writers, and yeah, I have a confession. My name is Viktor, and I was writing bugs. And I also hate bugs. So this is why I'm here today, and I'm trying to pitch you, let's call it an architecture, which we built with Mobius Framework from Spotify. And some words about Instructure at first. So we are working with education technology softwares. We are building learning management softwares and employee development systems. Our mission is help people grow from their first day of school until their last day of work. So basically 30 million of people are using our products worldwide. And yeah, we want to be a Kotlin-focused company in Hungary. So I should just highlight that we are hiring now. So you can meet us on the first floor. You can get a nice t-shirt from us if you take the test. Also, you can see our open positions. We have started a new office in Budapest. And we have a very special approach to QA. So automation is not optional at Instructure. We don't have manual QA people. We don't hire people for QA who can't code. We write automated tests wherever we can, and the teams are responsible for the quality itself. Also, we have a rule which I think coming from Microsoft, that the number of bugs can be higher than the double of the number of the team members. So this is the 2N rule at Instructure. Yeah, our war story. So as I mentioned, our office were initiated in February, and we had a deadline in June. So yeah, thank you, Instructure. The APIs were still forming. So we really didn't have the time to make any bugs, investigate or fix them, or with simple words, just suffer from bugs. We wanted to be control in every step in our application. So we have started to look for some frameworks, architectures, or tools to make this happen. And this is where we find Mobius from Spotify. So this is actively developed and used by Spotify. They are using it in production. So this is basically stable. The API is final. They won't have any breaking changes in the code. This is not something what we wrote. This is something we are using now. Mobius is a functional reactive framework to manage state evolution and side effects. So you heard a lot this today, the side effects. and state evolution. Why is it so important? Because unhandled side effects are basically bugs. So you can find the library itself on Spotify's GitHub page, and you can see Ahmed Navarra's Android at Scale presentation, which will help you more about understanding Mobius. I'm taking a lot from that presentation while I'm trying to show you what is Mobius, how to use it, and how it helps you to write more testable code. So, if we are thinking about a program, we always have at least 3 things in it. We will have states, which describes the program current state. We will have events, which happens in our application based on user interaction or some system events, global events, and we have effects. So we have to handle these events somehow. So that part of the presentation could be called, you don't have to write a lot of tests if you are using a lot of data classes. Why is that? Because data classes are basically immutable. And so by design, they don't have side effects. They can be well tested, and if we can trust in the language, and why wouldn't we? So these are basically constructor calls. So in our current example, we will model a login screen, and I want you and all of your imagination to imagine a login screen. So we have 2 input fields and 1 button. So this is what we build today, and this is what we test today. So we will have data classes called models. We will use these to represent states in our application. So when a user inputs an email or a password, we will save it in that model. We will have a Boolean variable called canLogin, which will be evaluated every time when the input change. So we basically can decide based on that variable if the user can log in. In other words, if we can enable or disable the login button. And we are keeping another Boolean variable to see if there is any other logging process in progress. So we have models, we need events. And these are also data classes. So more data classes, let's go to test. Yeah, in this example, we will have the email input changed event, the password input changed event when the user inputs something, and we will have the login requested event when the user presses the login button. And we will have the effects, which will happen based on the events. So events in your app will usually have some effects. We are using also data classes to represent these. Yeah, so in this example, if the input was right, so we will have a very dummy function for checking the input. But if it's okay, and we enable the button, the user can press it. So he can make an effect in our application because he is trying to log in. So one thing can happen that we will actually try to log in, and the other thing is that some error happens, so we have to show this to the user. So now what? We have a bunch of data classes. Now what? What will make this work? So this section can be called, what the hell is that diagram on the screen? Here you are, the Mobius loop, which basically the heart of the whole Mobius library, the heart of the whole architecture we will build. This is what will circulate the data models we built in the previous step. Yeah. So let's start with the easiest part of this loop, the user interface. So the user does something on the user what happens? This makes some event which sent into the Mobius library itself, which will take the current model, which is the current state of our application, and with that, it will hit our update function. The update function takes an event and takes a model, and based on that, it decides that what should happen. And yeah, it is declarative in the sense that it declares what should happen, but doesn't actually do that. And here's the first place where separation of concerns just step in. So this is a code part. We just say this should happen, and we don't care about how it will be handled. So, and yes, also this is a pure function, and why is it so good for us in the sense of testability? So pure functions taking inputs and giving outputs, they are deterministic, so by design they don't have side effects, and they can be well tested. The result of the update function will be a wrapper class called next. This is a Mobius special class in Mobius. So this will describe the effect this user interaction made, and the model changes what happened based on the user interaction. Okay, so this is actually how our update function looks like in this example. So our application receives the model, the current model, and the event what happened. So if the event is the email input changed, we will just copy the model. The email is what we received from the UI via the event from Mobius loop. So we are saving that in the updated model, and we will just evaluate the can login variable if the user can log in or not. And here is our super dummy evaluation function for that. So in this example, if the user fills the email and password fields, we will enable the login button. So back again to our loop. The user typed in something into the username field. That sends an event to the update function, which received the current model from Mobius. That changes the model. We are filling the model with the email what we received, and with the can login variable is updated, and this is what happened for now. Nothing has changed. Now the user inputs the password. We are sending again an interaction event to Mobius. This is the password changed. We are sending the current model, which is the model what we built in the previous step, already containing our email address. So the update function again takes this event, takes the model, fills the password in the model itself, and evaluates again the can login variable, which is now changed to true because we have filled all the emails and all the email address. So based on that model change, the user interface now seeing that it can enable the login button. In this step, we didn't generate any effects yet because the user actually didn't press anything. Yep. Just a sec. Okay. So right now, the user can press the login button itself, which will generate another event for us, which will be in this example, the onLogin requested event. So we will handle this like if the model is in the state that we don't in a progress and is in a progress in login, and we can log in because we filled all the data and it's in the correct form. We are changing the model again to the logging in state, and now we are sending our first effect. So the user actually tried to log in this step. So we have to have something which handles these effects, and that would be the effect handler, which will handle all the effects what the user did. So in this example, it will be basically we will hit the backend, we will wait for the result from the backend, and we will send the events what we generated based on the backend's response to the Mobius again, which will hit the update function, which will update the model, and which will update the user interface again. So we are again in this constant loop until you stop it. We are circulating the data. We are changing all the just the data what we need to make something happen because we separated all the concerns. So how the effect handler looks like now? We are receiving an attempt login effect, so we will attempt to log in. So at Spotify, they don't use Kotlin. They use Java, and with that, they are using Aries Java. But we don't have to do this because Mobius is working perfectly with coroutines. So in this example, we hit the backend, we are waiting for the result, and if any error happens, it's really important that we don't throw exceptions from the effect handler. So we will only provide events for the loop again. So if the login was successful, the loop will accept login successful event, and if it was failing, it's get login failed event, which will again hit the update function. Now the login successful, we call the onLogin success method, which will basically just dispatch an effect that we can navigate to home, which will go to the effect handler again, which will take the effect itself and say that, okay, if we can navigate to home, we go to navigate to home. So it will just send the event to the view itself that now we can switch pages. In this example, our fragment. So what we got? With the separation of concerns, again, we are separating the things what should happen and the how should happen part. So we can test these differently. We are maximizing the use of pure functions, which is great because they are deterministic, they don't have side effects, etc., so they can be well tested. Again, now what? So yeah, you saw that I have a main for there as well. So, but I'm not. Okay, so now we are understanding this constantly circulating loop in our application. Somehow we should connect this to the Android. And even though Mobius is not specially an Android library, we can do basically anything what we want with Mobius. So beware of the Mobius fragment, which has a lot of general parameters, which are basically our previously defined data models. So we will have models, events, effects, we will have a view, and we have extended this loop at Instructure with the view states and presenters because why not? And that made this model more effective. So we have another step between the update function and the UI, where we can send the event for the presenter, which turns it to the view state, and the UI can be rendered based on that view state. So this is the only two interesting lifecycle function in that Mobius fragment. Mobius fragment, which will have connection with its loop, with its update, with its view and effect handler. And this is basically just where we connect all these together. Interesting part is that we have a Mobius Android controller, which is used for Mobius loops, where we want to use the same loop, but we want to reach it from the different points of the application. And this is a good example while we are using fragments, because we have many lifecycle events when we are using fragments, and we want to use the same loop. We want to use also the same loop for the same features. So that's why it's a reasonable way to have a Mobius fragment for every feature. So using this, this is one fragment in our code base. So we're basically just overriding these abstract functions. We again separate the things into classes, which are basically, so with the exception of the effect handlers, they are pure functions. So again, can be well tested. Yeah, pure functions like the update function, like the effect handler itself, like the presenter itself, and the UI's render function. So we basically have, like, I don't know, 10 line length functions at max, and they are more readable, they are more testable, and altogether they can be more maintained. So again, now what? Now comes the testing part. So testing the update basically looks like this. So we just take the logic of the update itself, and we are providing a model itself. And we are just hitting it with some events. So in that example, we are taking a login model, which is by default empty. So this is the empty state of the UI. We check if the user inputs an email and the password and presses the login button, what we should see from the update. This is basically everything what we see from this update, that the user now can attempt login. And this is actually passes and describe all the logic what our UI does. So now we can just test the effect of what happens on the UI. So again, the expected event here that we can log in with the model where we have an email address and the password. So we are implying that the user attempts the login with the given data, and we can check if the expected event arrives into the Mobius loop or not. So with that, we are checking that the input generates the event what we want, and the event is handled in the way we want. Or in the effect handler test, we can test if our view is working as we want. So now our effect handler receives a navigate to home event, which will result in calling the view's navigate to home function. So we basically tested the algorithm behind the login function and the UI itself with just these libraries. So we are using the Mobius and the JUnit for having a more interesting measures for our test. We are using the Harmcrest library, and we are using mock for mocks. Also, we are using Espresso, and at Instructure we have an extended library for Espresso, which makes so easy for us to test. So using our library, which can be reached out from our GitHub page, you can just write tests extending the base page class and just providing the root containers ID. And we are writing some helper functions. We want to assert that the login button is disabled or enabled. We can do it with methods. We are writing more helper methods just to show the fragment what we want on our activity with the desired model. So with this, we can just take the fragment, the view, we can put the data in it, and we can check if the effect handler handles the input change well, and the view is changing how we want to. So we check the init state, we are loading a fragment with an empty model, and we can check that in this case, because the user didn't input anything, we just have our login button disabled. In another example, we will check the field state, that the user inputted an email address and a password, and now, based on that, he can log in. In this example, we should see the UI enabled. So, tested. The event source, what I didn't mention, is so basically you can give more event sources to Mobius loop, and this is basically system events. So you can handle connectivity changes, configuration changes with the Mobius loop. And again, you can test how your application reacts to this. Okay, so again, the minutes of honesty. So to be honest, I think I was the last one who sent the presentation for the conference. I was actually editing it this morning. So the example what we have seen, it's completely working. We can write any tests. I only have these tests. But with this technique, you basically can test everything within this feature. So 100% test coverage basically not happens, but you can reach something like this with it. If you are interested in the project, please let me know. Without this, I won't upload it. And I had to register a Twitter account for the conference, so I promise if anybody interested, my first ever tweet will be about that the project can be downloaded. So again, now what? Now, thank you for your attention. If you have any questions, hit me.
Thank you for the presentation. My question would be, does Mobius support state logging, so that you can see if there's a crash in an application, which states the user passed to get to this exception?
State login, so
state logging. So that because you're always passing through the update function, so probably if you log all the states the user passed, you could recreate how your exception in the application.
Yeah, so I think Mobius supports this. We didn't really try that, but we have seen it in many features of Mobius. So I didn't see a clear example for this, but I can imagine that, yes. So I don't have an exact answer for your question.
Okay, thank you.
How fast are the tests running with this framework? Because I saw the verify method with the timeout in there of 100 milliseconds, which is a lot, I would say, for a unit test.
So this is a really dummy example, but we don't have any problems with the text experience. We are using the Firebase test app, where you can basically pay for your time. So this is a must-have feature for us to have fast tests. So again, I don't have exact numbers for this, but they are really fast.
But these were normal unit tests, right? Or were they instrumentation tests?
Which one?
The first examples of the test.
Yeah, so the update function is unit test, the effect handler is unit test, and after the libraries description were unit tests, instrumented tests.
But the first ones, do you know like if they're running in 1 millisecond or 50 or 100, or you don't know?
I guess 1, but yeah, we didn't measure it.
Okay.
Okay, thank you again.